This video is going to show you how to bring in the defaulting customer data for this homework problem here. And this is an R video. So I want to show you how to bring in the file, and then I'm going to show you a couple other things. First off, we're going to show how to assign categorical variable labels or aliases. So we need to do that for gender and payment type. And we're going to see how to deal with dates. All right, so this is one of the problems. You can read all about the context of the company, or you can watch the SPSS video where I talk about it. Um, let's bring it in. So the first thing I want to do is show you that on my computer, I have a folder called Teach, and then in Teach I have another folder called Data, and in this folder I have a file called defaultsmall.csv. So that's the data that we want to bring in. And you have to remember that path. Okay, so I'm going to go over to R, and now we're going to type in that name. So we're going to do default, and let's just call it default. We have to give it some name. I want to call it default, but you could call it whatever you want. And this default is going to get assigned the value, what's returned from the function read.csv. Now you're going to see in R you get some help. So the first thing you have to do is pass to it where the the file itself is located. So remember, I have a folder called Teach, and I have another folder called Data, and it was called default small.csv. And I hit return, and notice everything seems okay. Now there's a couple things we can do. If you type head, you can look at the first 6 records. Let's say you wanted 10 records instead of 6. You'd say head default comma 10, and then you get to look at 10 records. Another really useful command that I would run is summary. So if you do a summary on default, what you get is either a frequency distribution for categorical variables. You can see enrollment type's been read in as categorical. So there's 132 instances of this date. For all numerical variables, you get a 5-number summary plus the mean. All right, couple issues. So first off, you're going to see that gender is 1 and 2, and it'd be much nicer if we could have male and female pop in. So if you go back to the course packet, let's go bring that up for a second, and I'm going to do a search for membership case. And what you're going to see is that right here on, well, your pages may be different than mine. I actually give you the code for assigning labels to this. Okay, so what I'm going to do is pay attention to this line right here. We're going to overwrite the original variable, which is, sometimes you don't want to overwrite an original variable, but we're going to do it here. And so the variable gender is going to get overwritten by a call to factor with the original variable gender, and then I'm going to pass it some labels here. So the value 1 goes to male and 2 goes to female by default. Okay, so it's going to start counting at 1. Now, if you're a lazy typist, you can just copy and then paste it. So let's go paste it. And just for fun, let's go back and look at the summary. And so now you're going to see, instead of getting a frequency distribution, instead of getting the 5-number summary, you get a frequency distribution. So this is the number of men and women in this particular data set. Let's just take a quick look at a head command, and you're going to see now gender actually is male and female. So the first customer is a male, the next 4 are females, and so forth. We should probably do the same thing for payment type. Remember that there are 4 different payment types. And again, I'm going to just copy it in. Let's talk about exactly what this command is going to do, though. So again, we're overwriting the payment type variable. Now, in this case, if you go back to the documentation, the value 1 was for book, then 2 was missing. 3, 4, and 5 are for statement, checking, and credit. All right, so I have to specify the level since I'm not just counting. if they were labeled 1, 2, 3, 4, I wouldn't need this argument. I could just give the labels command. But since 2 has been omitted, I have to specify exactly what the levels are, and then here are the meaningful names. All right, so let's now rerun this head command, and you're going to see, instead of seeing these numbers, we get to see the payment type. The other thing that we ran was summary, and you're going to see, lo and behold, we get a frequency distribution instead of the 5-number summary. All right, another issue is that this enrollment date is a string, and that's not a good idea. We'd like to make this thing a date. So to do this, I'm going to create a new variable in this data set. So I'll say default dollar, something like enroll. Let's call it enroll date. Make it something different. I'm not going to overwrite the original one in this case. And I'm going to call up the function as.date, which means I want to cast this this field as a date. So we're going to say default dollar enroll dt. So that's going to take this string variable up here and make it a date variable. So just treat it as a date. And then let's do a head. And what you're going to see is that now we have basically the same thing, except that this is actually a date instead of it being a string. Okay, so the advantage of this is that there are functions built into R that can extract parts of dates, like we can use the months command to extract the months. So let me just show you how we can do that. I'm going to run a table, and we're going to extract months of default dollar enroll date. And so now you know exactly how many people joined in each month. There's another function that's really useful, which is weekdays, and you know what day of the week people joined on. So that's how you can get you can bring the data set in and run frequency distributions on it.